Today, almost everything runs on computers. Banking operations and transactions are done on computers. Almost all communication devices run on computers. Transportation and navigation systems run on computers. Large industrial machines are operated by computers. Even this lesson you are watching is made possible by the computer device you are currently watching on. In fact, it would be safe to say that the whole world would come to a standstill if all computers go off. Well, not literally stop, but it would be greatly inconvenient. But did you know that the first computer was so big that it could fill up a whole room and could only perform 2 to 3 additions every second? Imagine having to wait for a minute for your computer to solve an equation like this. Thankfully, today we have super fast computers that can not only solve more complex equations, but can perform millions of operations every second. And not only that, today we have very small computers that can fit into the palm of your hand. So how did we transition from these large and slow computers to these super fast and smaller computers? Well, this transition was made possible by these remarkable friends of ours, the transistor and diode. But then what roles do transistors and diodes play in computers? To give us more insights into this, let's see how computers operate. You see, computers operate by interpreting electrical signals as binary, that is, numbers to the base of 2. For easy understanding, this is usually represented as ones and zeros. For instance, when electric current flows through the computer, it represents it as 1. And when there is no electric current, the computer represents this as 0. So by switching on and off electric currents at very fast intervals, a computer can interpret these signals into data and even store it as a piece of information for later use. But how can we create these electric switches that can switch on and off electric current at very fast speeds? Well, in the early years of computers, mechanical switching devices called mechanical relays were used. It consisted mainly of a circuit key and a control wire which had a coil. When current flows through the control key, the coil generates a magnetic field that closes the key and allows electric current to flow through the circuit. When the control wire is switched off, the circuit is disconnected. However, this switching process proved to be very slow when very large and complex computation was required. Also, it required hundreds of mechanical relays to perform very fast operations. That is why the early computers were very large. However, this challenge was overturned by the discovery of semiconductors and the development of diodes and transistors. So in the next lesson, we will look into how diodes and transistors transformed modern computers.